So we have already been discussing conditional probability as well as independent versus dependent. So I want to look at the sampling with or without replacement, the independent versus the dependent. Sampling with replacement means that we draw the first item, then we replace it prior to drawing the second time. These with replacements are going to be independent. They're samples from the entire population because I have placed that original item back in the sample to draw from. Sampling without replacement is where we draw one and then we don't replace it before we draw the second one. This is like the deck of cards. We have our 52 cards. I draw one and I keep it out. So now I only have 51 cards to draw from my second time. These are dependent and they are samples from remaining possible values. One of those has been removed. Example, an urn contains 3 red balls, 2 blue balls, and 5 white balls. So I'm going to look at, here's my urn. It's going to contain 3 red balls, 2 blue balls, and 5 white balls, which in this case we're going to draw as green. Okay. A ball is selected and its color is noted. Then the ball is replaced into the urn. So this is my first draw. My second draw, since I'm putting it back in, I'm going to have the exact same possibilities to look at. So I haven't changed my probability. These are independent events. We want to find the probability of selecting a red ball and then a white ball, which in our case are the green balls. So looking at this, the probability of a red is equal to 3 out of 10. That's on our first draw. And then we select a white ball from the urn the second time. So the probability of a white is going to be 5 out of 10. We want to find the probability of selecting these together. So we want the probability of a red and a white. This is my first draw, this is my second draw. Well, the probability of getting a red on the first draw was 3/10. I have an and, so that's going to mean multiplication. The probability of getting a white ball on the second draw was 5 out of 10. When I multiply across, that gives me 15 out of 100. If I simplify this, that's going to leave me with 3/20, or if I do my division, that's going to be 0.15. So the probability of selecting a red ball and then a white ball, if the red ball is replaced, is 0.15, or 15/100. Let's look at a second example of this. Okay, so we have our urn. The first urn is going to contain 3 red, 2 blue, and 5 white, which in our case is green. Then we're going to draw a second time. So a ball is selected and its color is noted. The ball is not replaced into the urn. A second ball is selected and the color is noted. Find the probability of selecting a red ball. So we want a red ball from the first one. Well, in this case, there are 3 out of 10. Now, our second draw, I took out a red, so now I only have 2 red ones, 2 blue ones, and I still have all 5 white ones. And we want to look at the probability of getting a white ball on the second one. So the probability of a white, and since I do not have the same number, I'm going to say given that a red was on the first time. Okay? Well, we still have 5, but this time it's going to be out of 9. So I don't have the same probability because I don't have the same number of balls in the urn this time. So the probability of a red on the first and a white on the second for this one is equal to the probability of it being red times the probability of a white given a red was drawn on the first one. So the probability of the red on the first was 3/10. The probability of a white, given that we drew a red one, is 5/9. I'm going to multiply across. That gives me 15 over 90, which is going to give me 1. What does that simplify down to? 15 90ths simplifies down into 1/6. If I change this 1/6 to a decimal, it's going to be 0.167. So the probability of selecting a red ball and then a white ball without replacement is 0.167. You'll notice that on both of these, we selected a red, then we selected a white. But you'll notice that the probabilities changed. It was because on the second time, we did not put that red ball back in. So that does change us quite a bit. Many times, we want to look at things using their complements. We've already discussed complements. They're the opposite of something happening. The complement of it being Sunday is it not being Sunday. The complement of it raining is it's not raining. It's the not. When using at least once, we want to use the complement because of the fact that at least once can take a lot into account, okay? An officer has 3 smoke detectors. In case of a fire, each detector has the probability of 0.9 of detecting it. If a fire occurs, what is the probability that at least one detector detects it? So when we want the probability of at least one, that is going to be 1 minus the probability that none of them work. At least one means that the opposite of none of them working. So the probability that none of them work is that they all fail. Well, what's the probability that they fail? If the probability that they work is 0.9, the probability that they fail is 0.1. There are 3 of them. So I'm going to look at 1 minus the first one failing times the second one failing times the third one failing. All 3 of them failing. Well, I need to do this multiplication first. So if I do this multiplication, that's going to become 0.001. 1 minus that is going to be 0.999. So 99.9% of the time, at least one of these smoke detectors will detect a fire. So the probability at least one detector works and detects a fire is 0.999. I'd like for you to go through and work with the complements, also work with the replacement, not replacement, and see if you have trouble. Let me know if you have any questions.